Hello everyone, myself is ACHYUTH KUMAR. We are going to learn about fuels. What are fuels? Fuel is defined as naturally occurring or artificially combustible material with carbon as a main constituent, which on proper burning act as a source of heat and light energy. So generally these are occurring naturally. Sometimes they are manufactured from the naturally occurring materials. So these are combustible, means they can undergo oxidation, which gives products and also heat energy, which on proper burning they act as source of heat energy and also light energy. The classification of fuels. Fuels are classified into two types based upon the following factors. The first one is occurrence or mode of availability. Second one is physical state or state of aggregation. The first one, occurrence. Based on the occurrence of fuels, these are classified into two types: primary or natural fuels, secondary or artificial fuels. Primary or natural fuels. The fuels occurs naturally and requires no chemical processing before utilization is called primary fuel. Example: wood, coal, peat, crude petroleum and natural gas. Secondary or artificial fuels. The fuels that is produced by changing chemical composition or naturally occurring substance is called secondary fuels. So these are on heating the primary fuels, they give secondary fuels. Example: coal is on heating, which gives hard material called coke. And gasoline is extracted from the crude oil or separated from the crude oil. Second one, physical state or state of aggregation. Depending upon the physical state, the primary or secondary, these are classified into three types: solid fuels, liquid fuels, third one is gaseous fuels. Based upon the physical state, the fuels are classified into solid fuels, liquid fuels, gaseous fuels. The solid fuels are again classified into primary fuels and secondary fuels. The examples of primary solid fuels are wood, peat, lignite, coal. Secondary fuels are charcoal, coke. Liquid fuels are again classified into primary and secondary fuels. The primary fuels examples are anthracite, crude petroleum. Secondary fuels are examples are petrol, diesel. Gaseous fuels are again classified into primary fuels and secondary fuels. The primary gaseous fuel example is natural gas. Secondary are example of coal gas, water gas, producer gas, even gobar gas, which are HCV and LCV. Before going to learn about HCV, higher calorific value, LCV means lower calorific value. So before going to learn about higher and lower calorific value, first we have to know about what is calorific value. Calorific value of a fuel is defined as the total quantity of heat liberated or released. Total quantity of heat released during the combustion of a unit mass of fuel or unit volume of fuel. There are two types of calorific values. The first one is the higher calorific value. It is known as gross calorific value. Higher calorific value defined as the total quantity of heat produced during the combustion of 1 unit mass of fuel or 1 unit volume of fuel and condensation of combustion products to room temperature. Okay, this is called higher calorific value. Simply is the higher calorific value is the simply amount of heat released during the combustion of unit mass of fuel, and also the condensation of combustion products to room temperature. Okay, so the room temperature is the 15 degrees Celsius or 60 degrees Fahrenheit or 288 degrees Kelvin. It is the room temperature. Okay, so this is about higher calorific value. Next, lower calorific value. What is meant by lower calorific value? It is also known as net calorific value. Net calorific value, NCV. Lower calorific value defined as the total amount of heat generated during the complete combustion of mass of fuel and escaping of unit products obtained in the process. That means here the amount of heat generated plus mass of fuel during the escaping unit products. That means, so here the heat released, total heat released during the combustion. So simply it can also gives the relation like this. Higher calorific value. It is also known as gross calorific value, GCV. What is meant by higher calorific value? It is the simply total quantity of heat produced during the combustion of 1 unit mass of fuel and also condensation of combustion products to room temperature. By the addition of these two heats, we get a higher calorific value. Secondly, lower calorific value, LCV. It is also called as net calorific value, NCV. Lower calorific value is defined as the total amount of heat generated during the complete combustion of one mass of fuel and also escaping of unit products obtained in the process. So by the combining these two heat energies, we'll get a net calorific value. It is defined as the quantity of heat liberated when 1 unit of fuel burned completely and also products are permitted to escape. That means the carbon dioxide and H2O are formed during the combustion and these are escaped from the point of combustion or place of combustion. Okay. Next, the formula. Practically available heat of fuel, LCV, equal to HCV minus latent heat of water vapors formed. LCV equal to HCV minus latent heat of water vapors formed. Next, formula of HCV. HCV is expressed as HCV is equal to weight of water into change in temperature by volume. Weight of water into change in temperature by volume is the HCV. Units: solids and liquid fuels. Calorie per gram. For solids and liquid fuels, the units of HCV or LCV generally taken as calories per gram, CAL per G, or kilocalories per kilogram, or British thermal units per pound, BTHU, B for British, TH for thermal, U for units, per LB means pound. Secondary, gaseous fuels, kilocalories per cubic meter. The units of HCV or LCV for gaseous fuels is kilocalories per cubic meter or British thermal units per cubic feet. Difference between higher and lower calorific value of a fuel. Higher calorific value or gross calorific value on left side. Lower calorific value or net calorific value is on right side. So higher calorific value is defined as the total quantity of heat produced during the combustion of unit mass of fuel and condensing of combustion products at room temperature. Whereas lower calorific value is defined as the total amount of heat generated during the complete combustion of unit mass of fuel and escaping of products obtained in the process. Simply, total combustion heat plus escaping of products. Here total heat, the total quantity of heat is produced and during the combustion, and also condensing of combustion products. It is called HCV. It is second one. It is measured of total heat of fuel. It is the measure of total heat of fuel. It is the measure of practical heat of fuel. Third one, higher calorific value includes latent heat of condensation of steam. Whereas lower calorific value does not include latent heat of condensation of steam. Fourth one, the total energy recovered after the combustion of fuel is comparatively less. Whereas in the case of LCV, the heat energy recovered after the complete combustion of fuel is completely high. This is about difference between HCV and LCV. Next, coming to DULONG'S formula for the calorific value of solid fuels. So what is the DULONG'S formula? Calorific value of a fuel can be calculated theoretically using DULONG'S formula. Calorific value can be calculated theoretically during DULONG'S formula. High calorific value HCV equal to 1 by 100 into 8080 into C, the percentage of carbon, plus 34,500 into H minus percent of H minus oxygen percentage by 8 plus 2240 into S means percentage of sulfur present in fuel. The units are kilocalories per kilogram. So it is also lower calorific value can given as LCV equal to HCV minus 9 by 100 into hydrogen percentage into 587, which gives the LCV value. 1 part of hydrogen mass gives 9 parts of H2O. 1 part of hydrogen H mass gives 9 parts of H2O, and latent heat of steam is equal to 587 kilocalories per gram. So this is about DULONG'S formula, and problems were given by using DULONG'S formula. So by using DULONG'S formula, we have to calculate HCV and LCV value, and from the problem they given carbon percentage, sulfur percentage, hydrogen percentage, nitrogen percentage, etc. And first we have to calculate GCV or HCV. So then we get the answer, and next substituting the corresponding value of equation 1 GCV, then finally we get the value of GCV. The expression for NCV is equal to GCV minus 0.09 into H into latent heat of steam. So latent heat of steam is 587. So NCV equal to 93,860. 9386.2 minus 0.09 into 7 into 587, and finally we get the value, and these are calories per gram. So by using this formula we can calculate DULONG'S formula, we can calculate HCV and LCV of any problem. I am going to explain what is proximate and ultimate analysis of coal sample and significance of this analysis, and also problems related. What is coal? How it is formed? Discuss the qualities of good coal. So there is no need to give information about good coal. Proximate and ultimate analysis of coal sample and its significance. What is coal? How it is formed? Coal is a primary solid fuel which is a non-renewable source of energy. which we can't regenerate the coal. It is highly carbonous matter. That means it contains carbon, which consists of carbon, hydrogen, nitrogen, oxygen, and non-combustible inorganic substances. These are the hydrogen, nitrogen, oxygen are the other constituents present in the coal. Formation of coal. Coal is naturally formed from the vegetable and animal matters which are decomposed under high temperatures and pressure. This process conversion of vegetable and animal matter into coal is known as coalification. That means all the vegetables and animal matter means the dead bodies of the animals. After the death of the animals, from the animals we are getting the oily fat from the animals, and also we are also getting oil from the vegetables after they decompose at a high temperature and pressure. This process of conversion of vegetable and animal matter into coal is called coalification. Analysis of coal. The analytical method designed to measure the particular physical and chemical properties of coal is referred as analysis of coal. What is meant by analysis of coal? The method of analysis is designed to measure the particular physical and chemical properties of coal. It is referred as analysis of coal. So by using analysis of coal we can measure the physical properties like melting point, boiling point, etc. And also we can measure the chemical properties. That means what are the constituents present in the coal, how much amount of carbon is present, how much amount of hydrogen is present, how much amount of nitrogen is present. So this analysis is called a chemical analysis. So the analysis of coal is classified in two types: proximate analysis, second one is ultimate analysis. Ultimate analysis of coal. Proximate analysis is an empirical method of analyzing sample of coal. Proximate analysis is the empirical method of analyzing the sample. Analysis is an empirical method of analyzing sample of coal. This method improves essential information about practical suitability and commercial classification of coal in any particular application. In other words, analysis helps in assessing the quality of coal. That means by using proximate analysis of coal we can assess or we can know the quality of coal. It determines the proximate analysis determines the percentage of moisture, percentage of volatile matter, percentage of ash, and fixed amount of carbon present in the sample of coal. The first one, the moisture. So how can we measure the moisture percentage? The steps. First one, a silica crucible of weight x grams. A silica crucible of weight x grams is filled with finely powdered and air dried coal of weight, that is y grams. The second step is to heat the crucible to temperature about 105 to 115 degrees Celsius in an electrical oven. After heating for an hour, the crucible is removed using tongs and cooled in a desiccator. Desiccator is a device which is used to cool down the hot materials. This step removes the moisture present in the coal in the form of water vapor. That means in the desiccator it contains calcium chloride particles. These can absorbing the moisture in the coal. Third step. The third step is that the weight of the cooled crucible. We have to weigh the cooled crucible, which considered the weight of crucible plus residue. Residue is the remainder after heating. After heating the coal, the remaining material is called the residue. Coal without moisture, the weight is equal to Z grams. The weight is equal to Z grams. First step, heating, cooling and weighing is repeated. Heating, cooling and weighing is repeated till a constant weight of crucible is applied. The process is repeated until we get the constant weight. The calculation for the measuring of moisture. Percentage of moisture is equal to weight of moisture divided by weight of coal into 100. Here weight of empty crucible is equal to x grams, weight of crucible plus coal is equal to y grams, weight of crucible plus residue is equal to z grams, weight of the coal sample is equal to y minus x grams, weight of the moisture is equal to y minus z grams. Therefore, percentage of moisture is equal to y minus z by y minus x into 100. Volatile matter. How can we determine the volatile matter? In order to determine the volatile matter, the first step is an anhydrous coal. An anhydrous coal. Anhydrous means without water or without moisture. Of known weight is filled in a crucible which is provided with a lid. A crucible which is filled with anhydrous coal and it is covered with lid. The next step is heat the crucible in electrical muffle furnace. Heat the crucible in a electrical muffle furnace. The device which can use it to heat the crucibles, which is maintained at 925 plus or minus 25 degrees Celsius. That means 900 to 950 degrees Celsius temperature. The crucible is removed after heating for about 7 minutes. The crucible is removed after heating about 7 minutes. The crucible is now cooled using desiccator and weighed. The amount of weight lost gives the amount of volatile matter present in the coal. The amount of weight lost gives the amount of volatile matter present in the coal. Volatile means easily evaporated material. Calculation. Weight of empty crucible equal to 8 grams. Weight of crucible plus moisture free coal equal to b gram. Weight of crucible plus residue after heating is equal to c grams. Weight of moisture free coal equal to b minus a grams. Weight of volatile matter equal to b minus c grams. Therefore, the percentage of volatile matter equal to weight of volatile matter divided by weight of moisture free coal into 100. That is percentage of volatile matter equal to b minus c by b minus a into 100. And next we are going to determine the ash content. How can we determine the ash content? The first step is the residual coal. The residual coal obtained from the analysis of volatile matter. That means from this method, volatile matter we get a residue. So that is the starting material for determining the ash content. The residual coal which is coming from volatile matter after removal of volatile matter, it is heated in a crucible without lid. The heating process is carried out in electrical muffle furnace which is maintained temperature is 700 plus or minus 50 degrees Celsius. That means 650 to 750. After heating for an hour, the crucible is taken out, cooled in a desiccator and weighed again. The process of heating, cooling, weighing crucible is continued till constant weight of ash content is obtained. Okay. The calculation. Weight of empty bottle equal p grams. Weight of crucible plus coal sample equal to Q grams, weight of crucible plus residue is equal to R grams, weight of coal sample is equal to Q minus P grams by Q minus P grams, weight of ash equal to R minus P grams. The percentage of ash equal to weight of ash divided by weight of coal into 100. That is, the percentage of ash equal to R minus P by Q minus P into 100. Fixed carbon. The amount of fixed carbon present in coal is calculated as percentage of fixed carbon is equal to 100 minus percentage of moisture plus volatile plus ash content. Finally, we get fixed carbon content. Now I am going to explain significance of proximate analysis. The moisture present in a coal is evaporated during the combustion consumes significant amount of heat in the form of latent heat of evaporation. So if moisture is present, it consumes heat energy. That heat energy is called latent heat of evaporation. This wastage in heat reduces the effective calorific value of coal. So the calorific value of coal is reduces due to the presence of moisture. Therefore, the coal with less amount of moisture content is always desirable. So moisture is less, that is a good coal, that is a better coal. Volatile matter. Presence of larger amount of volatile matter in coal leads to incomplete combustion of fuel. This also produces long smoky flame. Which considerably reduces the calorific value of coal. Hence, for a better quality of coal, it must maintain less amount of volatile matter. So volatile matter is very less, then it is a good quality of coal. Ash content in a coal is always considered as trash or waste. It is a non-combustible matter. It produces hindrance to flow of air and heat, thereby reducing the calorific value of the coal. So ash also increases the transport, handling, storage cost of the coal. Moreover, disposal of ash also causes big problem and adds additional cost to coal. Hence, presence of ash in coal is highly undesirable. Fixed carbon. Amount of fixed carbon in coal represents the presence of pure carbon content present in it. Greater the percentage of carbon, greater the combustion efficiency of coal. It is used in designing the furnace and shape of the firebox. Thus, a coal with a larger amount of fixed carbon has better quality. Ultimate analysis of coal. Ultimate analysis of coal provides percentage contents of carbon, hydrogen, nitrogen, sulfur, oxygen and ash, so as to yield better quality of coal. This analysis is also known as qualitative analysis. First one, carbon and hydrogen. The sequence steps of the determination of carbon and hydrogen are the first step is combustion tube. A combustion tube is filled with a known sample of coal of weight is P grams and it is burned in the presence of sulfur surplus oxygen. That is, the fuel, the coal is taken into the combustion tube and the weight of the coal is P grams and it is burned in the presence of oxygen. The combustion of coal yields two gaseous products. After combustion, it gives carbon dioxide and water, which are respectively collected in potassium hydroxide and calcium chloride tubes of known weights. So the CO2 is collected in KOH and H2O is collected in calcium chloride tubes. The amount of carbon present in KOH tube is determined using increase in the weight of KOH bulb. Okay, the carbon amount can be determined is like this. The KOH tube or KOH bulb can increase its weight, then it can determine the amount of carbon. Combustion reaction. C plus O2 gives CO2. Absorbing reaction is 2 KOH plus CO2 gives K2CO3. K2CO3 plus H2O. K2CO3 plus H2O. Therefore, percentage of carbon is equal to increase in weight of KOH by weight of coal sample. Increase in weight of KOH divided by weight of coal sample into molecular weight of carbon divided by molecular weight of CO2 into 100. Therefore, percentage of carbon is equal to increase in weight of KOH by weight of coal sample into molecular weight of carbon is 12 divided by molecular means atomic weight. C6 is 12. Therefore, 12 divided by molecular weight of CO2 is 44. 1 carbon 12, 2 oxygen 32. So, total weight is 44 into 100. So, by using the formula, we can calculate the percentage of carbon. Similarly, amount of hydrogen present in calcium chloride tube is determined using increase in the weight of CaCl2 bulb. Combustion reaction H2 plus half O2 gives H2O. Absorbing reaction CaCl2 plus 7H2O gives CaCl2 7H2O. Therefore, percentage of H2 equal to increase in weight of CaCl2 by weight of coal sample into molecular weight of hydrogen divided by molecular weight of water into 100. Therefore, percentage of H2 is equal to increase in weight of CaCl2 divided by weight of coal sample into 2 by 18 into 100. 2 is the molecular weight of H2, 18 is the molecular weight of H2O. Secondly, the nitrogen. How can determine the percentage of nitrogen? So, in order to determine the amount of nitrogen present in the sample of coal, determine using Geldahl methods. Geldahl methods. The sequence steps involved in determining the percentage of nitrogens are: the first step is the powdered coal of known weight is taken into Geldahl flask, a long-necked flask. The sample is then heated with a concentrated sulfuric acid. A sample of coal is heated with concentrated sulfuric acid H2SO4 in the presence of catalyst K2SO4 until the clear solution is obtained. The coal is dissolved in taken in concentrated sulfuric acid with the catalyst K2SO4. It is heated up to we get a clear solution. The clear solution is attained is made alkaline by treating with potassium hydroxide. The clear solution is made alkaline by treating it with potassium hydroxide. This process liberating ammonia, which is absorbed in the standard acid solution of known volume. This liberated ammonia, which is absorbed in a standard acid solution of known volume. The acid clear solution is again treated back with the standard base solution NaOH in order to determine the untreated acid. Okay, so the amount of ammonia released, it can react with the standard acid solution, and we can titrate with the sodium hydroxide. Then we get we determine the untreated acid, okay, or unreacted acid. Therefore, the percentage of nitrogen present in coal is then determined as percentage of nitrogen is equal to volume of acid used divided by weight of coal sample into normality into 1.4. So, this is the formula for determination of percentage of nitrogen. Next, coming to determination of percentage of sulfur. Amount of sulfur present in coal calculated by using bomb calorimeter. It is specially designed for bomb calorimeter. So, bomb calorimeter we know in the lower sections, lower classes also. In this process, the sulfur is converted into sulfate. The sulfate is then treated with barium chloride solution, which yields a precipitate of barium sulfate. Okay, the sulfur is converted to sulfate. The sulfate is treated with barium chloride. Barium chloride reacted with sulfate, which gives barium sulfate precipitate. The precipitate is so obtained is then filtered, washed and weighed. Therefore, the percentage of sulfur is in sulfur in coal is determined as percentage of sulfur equal to weight of barium sulfate by weight of coal sample into molecular weight of sulfur divided by molecular weight of barium sulfate into 100. Therefore, percentage of sulfur equal to weight of barium sulfate divided by weight of coal sample into molecular weight of sulfur is 32. Molecular weight of barium sulfate is 233 into 100. So by this formula we can get the percentage of sulfur. And D, ash. The ash percentage present in oil helps in identifying the faulty material or material causing abrasion and wear of the machine parts. So the ash content can easily measured and present in an oil. Next, oxygen. Amount of oxygen present in the coal is determined using the expression percentage of oxygen is equal to 100 minus percentage of carbon plus hydrogen plus sulfur plus nitrogen plus ash. So we get finally oxygen percentage. Next, significance of ultimate analysis. Ultimate analysis of coal gives the elemental description of coal. That means we can know the what are the elements present in the coal by using ultimate analysis. It determines the percentage of carbon, hydrogen, nitrogen, sulfur, oxygen, ash present in the sample coal. This analysis provides information regarding to the net content of the element in order to yield better quality. So we can know the net content of the carbon, hydrogen, nitrogen, oxygen, sulfur and ash also. So we can know this percentage, then finally we get the quality, better quality of coal. So that is the coal is very good quality or bad quality.